Hi everyone, this is Billy. If you've been following my videos, you know that I'm in the making of a big loop crystal radio. So I've just finished designing the circuit for that big loop crystal radio. I want to make this radio some options so I can do the regen. So this big loop crystal radio has the regen option. Let me show you the whole circuit diagram. So this is the whole circuit diagram. The top part is the FM part. The bottom part is the AM part, which consists of the medium wave 1, medium wave 2, and the short wave. So let's go to the top part first. Let's zoom into the top part. We have a small coil of 6 turns, and then we have tapping at the first turn, second turn, and the third turn. This coil is wound using 1mm copper wire, using the AAA battery as the frame. Once the winding is finished, you can take out the battery and just leave the wires, and this becomes an air copper coil. So we have the resonance circuit made up of the coil and this variable capacitor. It's better to use the air variable capacitor made of copper or aluminum. If you can't find it, you can still use the common PVC plastic film variable capacitor of around 22 pF. Then we have a tapping on the first turn after the ground to the MOSFET. We enter the source pole of the MOSFET. Then the hot end of the coil and the cold end of the coil enters the two gates, gate 1 and gate 2 of the MOSFET. The output is the drain pole. The drain pole will have the demodulated signal coming out from the FM circuit. This detection method we are using is called slope detection. If you don't know what is slope detection, you can look at my other video there called The Secrets of FM Crystal Radio. I recently refreshed that video, show you all the techniques and tips about FM crystal radio. You can go there to find out more. To filter out the radio frequency and leave behind the audio frequency, we use a bypass capacitor 100 pF. This is quite small because the waveform we are dealing with is at the high frequency range, close to 100 megahertz. So we need a small capacitor 100 pF to filter out the very high frequency and leave behind the audible frequency. Alternatively, if you don't want to use the MOSFETs as the detector, you can use any one of these Schottky diodes, which are very sensitive, starting with 1SS. I have been using 86, 192, and 106. Alternatively, you can use some other brand like HSNS 2850, or you can use even a crystal. I've tried to use the Fusco crystal. It can detect FM to certain extent, but the output volume is just 1/4 or a quarter of what the MOSFET can do. Okay. So the dotted line here means you can either use the diode or you can use the MOSFET. Okay, then you have the two antenna feet. If you have only one single telescopic antenna, you can connect to FM1. If you have a second antenna or a drop cable of the same length, which is usually 1 meter to 1.5 meter, then you can connect to this point FM2 here as well as the antenna for FM. Okay, so that's the output of the FM circuit. it goes to the other circuit, which we'll touch on later. Okay, so this is the FM, and let's go to the MW. Okay, the MW, I mean the AM amplitude modulator circuit. We have the two medium wave coils. I have two big loop coils, one for receiving some stations close to me on an island on the ocean, just 4 to 5 kilometers away from my home. The other big loop coil is oriented horizontally, flat. This one is for receiving from the transmission station over the mountain, which is around 15 to 20 kilometers away from my home. So this one we call it medium wave 2, another big loop coil. Then you have the short wave coil, which is one turn of soft copper pipe, those used in the air conditioner as the condenser coil. Those coil we can wind one turn with 1 meter diameter. Okay, the tapping points are similar. So for the medium wave big loop, the tapping point is the total number of turns is 8 to 9 turns. Tapping point is at the first turn and the third turn. For the short wave coil, it is one turn. The tapping point is at different part of the one turn. So this is like first tapping point is 0.25 or 1/4 of the coil, 1/4 of the circle, or 1/4 of the turn. And then the second tapping point is at around 1/3 of the coil. Okay, 1/3 of the coil. Okay, and all these different tapping points are fed to 3 switches. They are the band switches. So together they will allow us to connect to the different coil, to the different tapping points as well. So medium wave 1, medium wave 2, and the short wave. And then the ground connection point and the hot end of the coil, whichever medium wave or short wave is selected, is fed to a 490 PF, a big aluminum air coil, or you can use the PVC coil of similar size. And then it will form the resonance circuit. The selected coil by the switch and this variable capacitor forms a resonance circuit. If you are using the diode as the detector, you can connect to this middle tapping point, which is around 1/3 of the coil, which will go into one of the detectors. You have more freedom of choice of detector because the medium wave is more tolerable to any different type of detectors. You can use the same Scotchy diodes like 1SS86, or you can use the germanium diodes like 1N34A, 1N60, or even a crystal. Then it will fit to the output point. The output point, we have a 4700 PF, a larger capacitor to filter out the radio frequency and leave behind the audible frequency. If you are using the MOSFET as the detector, then you have more connections. You have the two gates, gate 1 and gate 2. Gate 1 connects to the grounding point or the cold end of the coil. Gate 2 connect to the top end of the coil or the hot end of the coil. Then you have another input called the source S pole. The S pole normally connects to one extra turn outside of the resonance circuit. However, here we have a more complex Regen setup. So you have a Regen variable capacitor that adjusts the level of Regen, and also the switch that controls whether you fit through that Regen variable capacitor. If the Regen is off, that means you are using it as a crystal radio. The source pole of the MOSFET will connect directly to this tapping point, which is one extra turn outside the cold end of the coil. However, if you want to try the regen function, you will connect to a variable capacitor instead. The port of the variable capacitor will determine how much regen you get, or how much signal is divided between this extra tapping point versus the ground or the hot end of the coil. So you can adjust this level, get the right amount of voltage, and then feed through the MOSFET to do a regen. Okay. So this is the top view of the MOSFET we use, called 3DQ. The official name is 3SK-143, but the nickname or the label on the chip itself is actually 3DQ. Okay, it is used, originally used in some television antenna amplifier. It is known to be usable in crystal radio as well because of the low voltage requirement. It is nearly zero voltage. Not exactly zero, but very close to zero voltage that you need to drive this MOSFET to turn it on. Okay. Okay, what else we are going to do? Okay, now we have the FM output and the AM output. The FM output and the AM output will be selected. If you want to hear the FM radio, you will flip the switch to the top, and then you will get the output for the FM. If you want to hear the AM, which means medium wave 1, medium wave 2, or shortwave, you flip the switch to the bottom, then you will connect to the output of the AM crystal radio. Okay. Then you go to this Benny volume control. So if you flip the switch like what you see here, it will connect through a setup called the Benny setup, which has a 0.1 microfarad fixed capacitor in parallel with a variable capacitor of around 500K or sometimes 1 mega ohm. This will be usable if you are using a diode or a crystal to condition the output such that you will hear much better, clearer output. But if you are using a MOSFET, the effects will not be that great, or even there's no effect, zero effect for MOSFET because of the different switching effect of the MOSFET instead of the diode. Okay, so this is the Benny, but if you flip the switch to the top, the fixed capacitor will be disconnected, and this will simply become a volume control, just adjusting the loudness of the crystal radio output. Normally people don't use a volume control for crystal radio because crystal radio output is already quite weak. You really don't need a volume control. Usually people just tune the station a little bit off, so the output will be much lower. So they use the variable capacitor indirectly as the volume control, but I don't like that idea because that will mean you are not hitting the center frequency. That means it may have some noise or even some interference. So I want to have a volume control because at night I want to listen to the radio through the earbud. If it's too loud, my ear will go bad. So I'd rather have a volume control, and this serves two purposes: Benny and volume control. Okay, then the next thing we are going through before we get to the earbud or the output, it is this setup called the crystal regen switch. Actually, this S5 switch is used together with the S2 switch. We said that S2 switch will be turned on to the regen function when you're using the MOSFET, right? But if you're using the diode, there will be no regen function because diode is like a passive component. You can't trigger it to any regen function. But if you're using a MOSFET, you flip the switch to S2 to regen function, and at the same time you flip the switch S5 to the regen function as well, which is at the bottom. If you flip this switch to the bottom, instead of connecting directly to your output, it will go through a 3-volt battery. You will put a 3-volt battery, positive and minus, in series to your output circuit, which means you will power the MOSFET indirectly through this output, and this will create a circuit that allows the regen function to operate, and the 3D will kick into the regen mode, and it will like boost the output multiple times. So in that case, you can hear some weak station. You will also have some similar function to the FM circuit as well. It will boost the output a bit, so you can hear more clearer FM radio reception. Of course, if you turn on the regen function, you can no longer call this a crystal radio, because now you're using a battery in a regen function, right? So this radio has two functions. Either it is a crystal radio or it's a regen radio, determined by where you flip those switch S2 and S5. Okay, so now we finished the regen function. Let's go into the impedance matching function. I use the China manufactured KPB02 as the impedance matching transformer. You can use other Regen T7, I forgot the part number, 751 or 752 or 725, I forgot. It's the Regen transformer. You can use that as an impedance matching transformer, or in China they clone that to T725 or T751, I forgot which number. But anyway, all these are set up in an auto transformer setup. Auto transformer means it has no primary or secondary coil. It is just a single inductor, single coil. And you connect the first turn of that single coil to your ground, and then you connect your input and output to different turns of this single inductor. It will become an auto transformer in that way. It will still do the transformer function, match your impedance, and do the nice thing so you can hear your high impedance output through a low impedance earbud or even a lower impedance speaker. Okay, it's especially useful when you have the regen function turned on. You may be able to power your speaker this way because of the regen function. Even FM, you can power the speaker only through the regen function. But if you connect or flip the switch to a crystal radio function, the FM radio can never drive a speaker, because the slope detection we are using here, it is an approximation, and it is just allowing you to listen to the FM radio through an AM radio mechanism. So you can't really push it to a high enough output that can drive the speaker. Even if you are standing next to the FM transmitter, you won't be able to do that because of the detector circuit we are using. It's not a direct detection circuit. It's an indirect circuit that won't be able to boost up the output even you have a powerful station next to you. Okay, but if you are using an AM medium wave or short wave, you may be able to power the speaker depending on how close you are to that transmission station and how long is your antenna and how good is your earth connection. Okay, so now we can connect any speaker or earbud or headphone to this J1, and then you can select the different turns of the coil to match the impedance. To avoid filling up my face plates, I didn't put in a variable. I didn't put in a band switch to select this coil, these turns. But if you have a bigger face plate, You can include two band switch, one to select this output from the detector, and another band switch to select the connection to your earbud or speaker. That will be easier to make the adjustment. But right now I'm using alligator clip, just simply because I'm running out of faceplate, no more real estate on my radio. Okay, so the bottom here is some fine detail about each of the connection. You can copy it. I will post a link to this circuit diagram so you can get a nice hard copy. You can reference. This is by no means the best radio. It is just a radio that suits me because I use big loop and I just want to be able to switch to the different FM, AM or shortwave stations easily. This circuit you can replace the big loop coil with a small coil of ferrite coil or other smaller size air coil. Just make sure the right number of turns can match your variable capacitor. Okay, so that's all I have for today. Thanks a lot for watching. I will put the link to the YouTube description for you to download these diagrams or other useful information. Thank you. Bye now.